Okay, so welcome to the next talk. So it's about credible persuasion. Will Liu is going to give the talk.
Good morning, everyone. Thank you very much for coming to our session. So today I want to tell you about this research that I've been working on with Xiao, who recently graduated from Penn State and will be joining UPenn in the fall. So in this paper, we're trying to understand credibility issues in Bayesian persuasions. And in particular, these are settings where one party tries to use information to influence another party's decision. Now, in the most basic Bayesian persuasion setting, there's going to be a sender who provides information and a receiver who receives information before taking an action. And the sender is going to provide information by committing to an information structure, which is mapping from some payoff relevant state to a distribution of messages. For the sake of concreteness, let's think about the example of a school trying to persuade an employer to hire its students. Now, the school is going to provide information by designing and then committing to a grading policy, which is a mapping that takes the student's ability to a distribution over grades. The employer does not know the student's ability, but she's going to have a prior belief. And upon observing the grade, she's going to be able to draw inferences on the student's ability through Bayesian updating. Now, a key assumption of this literature is that the school, in our example, needs to be able to commit to the distribution, the grading policy. And more generally, the sender needs to be able to commit to its information structure. But in practice, the full details of information structure are often not observable. So, for example, the school's grading policy can be a very complicated mapping from the student's ability to grades, and may be hard to monitor. And if the sender's choice of information structure is not observed by others, then this creates scope for undetectable deviations, and we might think it might be hard for the sender to credibly commit. But what is often observable is the distribution of messages that is generated by the information structure. So in the school example, if the school is grading a population of students instead of just a single student, then even if I don't observe the grading rule that the school is using, I might still be able to observe the fraction of students getting A, Bs, or Cs. And in the case of a credit rating agency, even if I don't observe how these ratings are assigned, I might still be able to observe the fractions of securities receiving a AAA rating. So what we took away from these observations is that it is often a lot easier for the sender to commit to the distribution of messages than it is for her to commit to the full information structure. So one of the first things that we do in our paper is to introduce a notion of credibility for Bayesian persuasion that formulates this idea. So in particular, we're going to say that the sender's information structure is credible if, given the receiver's responses, there is no other information structure that gives the sender a strictly higher payoff while at the same time still maintains the same distribution of messages. So to put it in a different way, what we're trying to capture here is that any deviation that maintains the message distribution is going to be undetectable. So in order for the sender to be credible, these undetectable deviations must not be profitable. Now, this may seem a little abstract, so next, let me illustrate the key idea of our credibility notion using two very simple examples. So first, let's suppose we're looking at a used car seller who's trying to sell 10 cars. Now, 3 of these cars are good, 7 of them are bad. And for this example, let's assume there's an exogenously given prevailing market price so that the seller always wants to sell the car, regardless of the quantity. Now, here are the payoffs. The important thing here to notice is that if a car is getting sold, then the seller doesn't care if this car is good or bad. But if a car is not getting sold, then the seller actually prefers that car to be the good car because he's going to receive a higher reservation value from this good car. On the buyer's side, the buyer is she's willing to purchase the car as long as she believes the car is good with at least 1/2 probability. The buyer, of course, doesn't know the quantity of the car, but the sender can provide information through using a rating policy. And this is one particular rating policy that the buyer can use, and in particular, this is the completely uninformed rating policy. Now, in this rating policy, the seller groups all 10 cars together and give them the same rating. The red dots in this graph are the good cars. The black dots are the bad cars. When the buyer observes a rating from this rating policy, she's going to believe that the probability of getting a good car is less than 1/2, so she's not going to buy any of the cars. Now, another alternative rating policy that the seller can use is the fully revealing rating policy. In this rating policy, the seller simply labels the good cars as good and the bad cars as bad. So upon observing the rating, the buyer is going to learn the quantity of the car perfectly, and she's only going to buy the 3 good cars. So what is the optimal rating policy? This is the question answered by Kamenika-Gensko. So in the optimal rating policy, the seller essentially passes 3 good cars along with 3 bad cars and fail the remaining 4 bad cars. When the buyer sees the passing grade, she believes the probability of getting a good car is 1/2, and this is exactly enough to get her to buy the car, and she will refuse to buy the failing cars. So in this case, even though there are only 3 good cars, the seller is actually able to sell 6 cars. But in this example, if the only thing that the buyer observes is the distribution of messages, in other words, in this particular example, the fractions of passes and fails, then the seller actually has a profitable and undetectable deviation. So this optimal rating policy is actually not credible. So to understand why, notice that from the buyer's perspective, all that she sees is that there are 6 passes and 4 fails. So one thing the seller can do is to simply swap a good car from the passing grade with a bad car from the failing grade. This does not change the fraction of passes and fails, so this deviation is not going to be detectable. But this deviation is also profitable because the seller is still selling 6 cars, but out of the 4 cars that he's not selling, one of them is actually a good car, and he's getting a higher reservation value out of it. Because there's an undetectable and profitable deviation, this rating policy is not going to be credible. Now, you may be wondering, in this example, is there any credible rating policy under which any car can be sold? And the answer is no. And to understand why, let's suppose by contradiction that some cars are sold under, there's a car that's getting sold under some rating policy. And in particular, let's assume that this car is sold after a rating A is observed. Now, in order for the buyer to be willing to buy this car after seeing rating A, it has to be that the rating A contains at least as many good cars as bad cars. But we also know that overall, the total number of bad cars is more than the total number of good cars. So that tells us there has to be another rating B, which contains strictly more bad cars than good cars. So after observing rating B, the buyer is not willing to buy a car. But then again, the seller will have a profitable and undetectable deviation by swapping a good car in rating A and a bad car in rating B. And so this rating policy is not going to be credible. And as a result, no car can be sold under any credible rating policy. So this is a very stark example that illustrates how credibility can severely limit communication under certain preference configurations. In the next example that I'm going to show you, we'll see that under different preference configurations, things can actually look very different. So let's suppose that instead of used car sellers, we're looking at a school who is trying to place 10 students. Now, 3 of these students are good. 7 of them are bad, just like before. And also, just like before, the school wants to place a student regardless of his ability. Now, here are the payoffs. The important difference here from the previous example is that now, when a student is not getting hired, the school doesn't care if the student is good or bad. But if a student is getting hired, the school prefers a good student getting hired over a bad student getting hired. The employer side is the same as before. She's willing to hire as long as she's convinced the student is good with at least 1/2 probability. Now, in this example, the optimal rating policy is still the same as before, where the school passes 3 good students and 3 bad students and fail the remaining 4 bad students. The employer is going to hire the passing ones and refuse to hire the failing ones. But in this context, this rating policy, this optimal rating policy actually is credible. And the reason is, without changing the distribution of grades, in other words, without changing the fractions of passes and fails, the school has no incentive to swap a good student from the passing grade with a bad student from the failing grade. Doing this swapping will get an additional bad student hired, but this will come at the expense of a good student. And the school's preference is such that it prefers a good student getting hired over a bad student getting hired. So this deviation, even though it is undetectable, it is no longer profitable for the school. And because there's no profitable and undetectable deviation, this rating policy is credible. And in this particular case, the school is able to achieve the optimal full commitment payoff, even though it is only able to commit to the distribution of messages or distribution of grades in this particular example. So in the previous two examples, we saw that depending on the preference configuration, credibility can have drastically different effects on the scope of possible communication. The key difference between these two examples is that in the used car example, when the car's quality becomes higher, the buyer has a stronger incentive to trade, but the seller has a weaker incentive to trade. Whereas in the school example, when the student's ability becomes higher, both the school and the employer have a stronger incentive to trade. So the results in our paper generalize these observations and essentially shows that the alignment of players' marginal incentives is going to play a crucial role in determining the scope of credible persuasion. So I hope through using these two examples, I've illustrated the key idea of our credibility notion. I think now would be a good time to compare our model with two canonical models of communication in the literature, namely cheap talk and Bayesian persuasion. So in Bayesian persuasion, the sender is given full commitment power. So the sender's choice of information structure is unrestricted. By contrast, in cheap talk, the sender has no commitment power whatsoever. So in equilibrium, the sender has to have no profitable deviation to any other information structure. In our model, we also need to worry about the sender deviating to other information structures, but we only need to worry about deviations that maintain the same message distribution. So in this sense, essentially our model is one with partial commitment that sits in between cheap talk and Bayesian persuasion. Now, we can also see the differences between among these models in the context of the two examples that we just saw. Now, under Bayesian persuasion, the optimal full commitment information structure is the same in both the used car example and the school example. In cheap talk, because the sender always prefers the receiver to take a higher action, so in equilibrium, the only equilibrium in both of these two examples is the Babel equilibrium, where no information is being transmitted. Now, in our model, in the used car example, there's no information transmission, but in the school example, the full commitment, the optimal full commitment information structure is actually credible. So our model actually makes a distinction between these two settings. And in fact, one of the takeaways from our paper is that it speaks to why certain industries can disclose information through their own rating system, while other industries have to rely on third-party certification or warranty to address the problems arising from asymmetric information. So in the interest of time, let me just briefly summarize what we do in the paper. So in the paper, we propose a new notion of credibility for Bayesian persuasion problem based on the idea that the sender can commit to only the distribution of messages instead of the entire information structure itself. We then use tools from optimal transport theory to show that the credibility notion is equivalent to a cyclical monotonicity condition on the induced outcome distribution. And this is analogous. This is a condition that's analogous to what has been studied in decision theory and mechanism design. Now, with this characterization in hand, we then show that information transmission depends critically on the alignment of players' marginal incentives. And this generalizes what we saw in the example today. Lastly, as an application, we apply our approach to the market for lemons. And in particular, in the canonical MWG setting of adverse selection, we show that the seller cannot credibly disclose any information to address the inefficiencies arising from asymmetric information. So that's the paper. In terms of related literature, we're obviously not the first people to think about limited commitment in Bayesian persuasion. So both the both the paper by Lipnowski, Ravid, and Shishkin, and the paper by Min consider a different kind of limited commitment in Bayesian persuasion problem. So in both of these papers consider a sender who can revise the messages from the information structure with an exogenous probability. There's also extensive literature that uses repeated interaction as a source of commitment in communication games. Lastly, our model can be thought of as giving the sender quotas for messages. And this is similar to the literature on quota mechanism that uses message quotas to enforce truth-telling. So that's all I have. Thank you very much.
Thanks for the nice talk, Will. Questions from the audience? Oh, we got a lot. Yeah, that's in order. Go ahead.
Can you say something about the class of preferences in which the credible mechanisms, it's not that this class of preferences large, because it shows some very specific example in which the credible persuasion is empty set.
So you're asking the class of preferences under which the credible persuasion is not empty, or so essentially in the paper, the results in our paper show that it boils down to the modularity of the senders and the receiver's preferences. When the sender's receiver's preferences are anti-modular, so for example, if the sender's preference is supermodular and the receiver's preference is submodular, then essentially there's the only kind of credible persuasion communication is no information. When the sender and receiver have co-modular preferences, under some weak regularity assumptions, then we can at least show there is a way of credibly communicating information that is better than no information. And in some more specific examples, for example, if the receiver's action is binary, if it's only an up-down decision, if the receiver's action is binary, so let's say if it's only an up-down decision, accept or reject, then if the preferences are both supermodular, then the full commitment, optimal full commitment information structure actually is credible. Yep.
Yeah, next question.
So I guess I have a question with your definition of observable deviation. So here you are thinking about the single shot game where you only observe one signal from the distribution. But like in your definition, you are assuming the distribution, the deviation of distribution is observable. So I guess I have two questions. So the first one is it more reasonable to think about some, say, epsilon deviation from the distribution, because you only observe samples? And my second question is, I think some research, they relax the commitment power by doing the repeated game. And I think some paper, they give characterizations on the condition where in repeated game, the payoff, the sender's payoff can achieve the Bayesian persuasion optimal payoff without commitment power. Is there a relationship between their result and your result here? And I guess in all, to say my question is, can you give some justification on why you are considering a single shot game, but you're defining the observable deviation as the deviation in distribution?
I see. So in terms of the literature on repeated game, there is extensive literature using repeated game to think about credibility in persuasion problems. I think the one that's closest to ours is probably the paper by Renaud, Solon, and Vieille. So in that paper, they think about, they have a receiver which essentially plays a quota strategy that uses quota to enforce truth-telling from the sender. So in terms of using quota to enforce message distribution, this is actually, the idea is similar to what we're doing here. But the focus of that paper is to enforce truth-telling from the sender. And here we're trying to characterize what is the scope of credible persuasion? When is persuasion possible when we have this credibility concern? In terms of repeated dynamic game versus sample deviation, I view these as two ways of getting at a similar idea. So you can think about dynamic game is more, I think dynamic game is more suited to studying environments where you observe samples over time, and these samples arrive slowly And the states can either be observed ex post or not observed ex post. What we're studying in this paper is that it's studying where the state is not observed. The only thing we observe is the sample of messages. And in particular, in the school example, or in the rating policy example, because the school is grading a large cohort of students, a cohort of students is graduating at the same time, you can think of having a large sample as a good approximation, at least in for every single cohort that is on the market.
Okay, so we have maybe one last question.
Sorry, I kind of have a similar question on the repeated interaction part, but I guess my question is more leading to like reputation building, because you're talking about credibility, and I do feel like maintaining a sound reputation does make sense, or perhaps I'm not understanding your model correctly. So when the company does hire the student, do they get to know which one is like good or bad, or do they just know like the aggregate summary statistics?
So in the model that we have, the state is never revealed. It's a single shot game. The only thing that is, from the receiver's perspective, the only thing the receiver sees is essentially the distribution of messages and the particular grade that the student that it's looking at is receiving. So there's no, in our model, we don't have any dynamic component to the model. This is only a one-shot interaction.
Okay, cool.
Yeah.
Thank you.
Let's thank the speaker again.